Hello and welcome to my talk on optimizing measurement in internet-based research, which is based on my PhD thesis that I handed in at the University of Constance. The thesis itself investigated empirically different methods for internet-based research that promise to optimize assessment and try to find out whether those promises actually held true in actual studies and investigations. It is publication-based, which is why I will present to you the results from 3 different papers. They are all in the area of assessment via internet and smartphones. The first one investigates the influence of response scale format in internet-based surveys on non-response, meaning dropout and missing data. The second one investigates the validity of the assessed information via different response scales, so the actual information contained in the responses. And in the third one, we venture into the newer area of assessment via smartphones, and we investigated whether sensor data from those smartphones can be implemented to optimize assessment. Overall, we try to provide researchers and practitioners with methodological advice and best practices in their own projects. The response scale that we investigated in the first 2 papers is the visual analog scale, and here you can see an example of it. You have the normal typical item text, a question, and then you can agree to a certain extent with the answer, and instead of radio buttons where you have to choose which of 5 or 7 radio buttons you click here, you have a continuous line and can click anywhere on the line to indicate your response, meaning it is, from a theoretical point of view, a lot more fine-grained than other types of scales. It has been shown before that visual analog scales have better measurement properties and distribution of responses than Likert type scales, but there have been mixed findings with regard to dropout and non-response before, which is why we investigated it in our first paper in an e-health intervention, and this was published in the Journal of Medical Internet Research. The eHealth intervention itself is a web-based aftercare program for cardiac patients. So after you had surgery after cardiac incidents, you usually go into a clinic for rehabilitation where you learn to do a certain amount of physical activity and eat in a certain way. And after this rehabilitation clinic, you go home and you are expected to still adhere to those guidelines. But it's usually quite hard for people to follow through when they are at home and no one is watching. And this lifestyle intervention was dedicated for people to actually increase their adherence after they get home. With one example here is feedback on their physical activity, but also other implementations. Before this lifestyle intervention starts, there's an extensive questionnaire that takes about 30 minutes with a lot of questions about health-related constructs and their lifestyle. And we actually implemented an experimental manipulation here. This extensive questionnaire was either presented with the visual analog scale response scales or Likert type scale response scales, and participants were randomized to one of those conditions. So the questions were exactly the same, but people either got this top response scale or the bottom response scale to indicate their answers. The sample itself consisted of about 450 participants with a wide age range and a mean age of over 50 years, and only a bit more than half of them graduated from high school or earned a higher degree. So it was a very diverse sample also with regard to socioeconomic status and education. The results with regard to dropout are shown in this graph. So this is a dropout curve. On the y-axis, you can see how many participants are still remaining in percent. And on the x-axis is the questionnaire progression or the item number. So from left to right, you progress through the questionnaire, and during that time, people can drop out whenever they want. They just close the survey. Here, the darker blue line indicates the survey via visual analog scale, and the lighter line is the Likert type scale. And as you can see, more people remained throughout the questionnaire when the questions were presented in the visual analog scale format. 68% versus 59%, which was a significant difference. So about 9% more remained till the end of the questionnaire if it was presented in the VAS format. This lower dropout in the visual analog scale condition could possibly be due to motivational advantages. So previous studies have found that people prefer the VAS format to radio button scales. In addition to that, the study represents the validation of visual analog scale in a very specific sample with regard to age. So it was an older sample than typical internet-based research sample and also education. So overall, it worked very well also in this sample. For statistical tests, the power could be increased because standard errors for the same constructs assessed via visual analog scales were lower. And this effect size of 68% versus 59% remaining might also have real-life impacts because this is a lifestyle intervention which aims to increase physical activity and dietary behavior to actually prevent another cardiac incident. So there might be real-life consequences of this dropout phenomenon. Coming to the second paper, here we investigated visual analog scale and Likert type scales not in a lifestyle intervention, but in internet-based personality questionnaires. And the question in this paper was, which was published in Behavior Research Methods, whether the more fine-grained answer that people can give on this scale is actually valuable additional information, or maybe it's just measurement error, or it might even confuse people if they get too many options. So there might not be real information contained in this more fine-grained answer, but it might be something else. And our hypothesis is that visual analog scale provide more valid information than Likert type scales. And to investigate this, we first needed a criterion to say how much information is contained and how much measurement error is contained. And in our case, we chose age for this, as it can be assessed with more or less no measurement error. So people had to indicate their age in our study, and in addition to that, we used personality scales that showed a correlation with age in the past. So excitement seeking has a negative correlation with age, conscientiousness a positive correlation with age, and narcissism also a negative correlation with age. And in our study, every participant answered all of these personality scales in both formats. So on the top here you can see the visual analog scale format, on the bottom the Likert type format, and every participant answered all scales in one format and then in the other. And this was counterbalanced, so the order was changed for each participant, so there were no order effects. We then investigated whether we can predict age better from one of these types of scales. The sample in our study consisted of about 900 participants with a mean age of 33 years. And to find out how much information is contained, we tried to predict in a regression model the age of participants from their answers on these personality type questionnaires. And first we entered all Likert type scales, so conscientiousness, excitement seeking, and narcissism measured via Likert type scales. And then in the next step, we added the same scales but measured via visual analog scale and saw whether we explain more variance if we include those answers as well. And as you can see by the base factor here, there is additional information in the visual analog scales. And in more detail, it was shown that this was only because of the excitement-seeking scale. So for conscientiousness and narcissism, there was not more information contained, but for excitement-seeking, we explained about 2.5% more variance than if we only include the Likert type scale and measured excitement-seeking via this one. In this study, overall, more or less both scales showed identical information with the one exception of excitement seeking. The more fine-grained responses did in most cases not lead to better measurement, but they also did not include error variance. So there was no downside to implementing the visual analog scale here. In the third paper now, as I mentioned before, we go into the area of smartphone-based assessment, and we investigated here whether smartphone tilt can be used as a measure of well-being, so whether data from the objective smartphone sensor can be used to infer something about the subjective well-being of the person who owns the smartphone. Smartphones itself offer a lot of advantages for psychological research, and one of those is the technical data that can be gathered with these smartphones in the form of GPS or Bluetooth that's now used for the corona distance measuring. And the sensor I investigated is the gyro sensor, which gives information about the position of the smartphone in space. The theoretical background is that body posture and well-being are associated, so you can think of it as a slumped posture is usually associated with lower well-being in comparison to a more straight posture, and this was investigated very early on. In addition, smartphones itself offer the possibility to identify activities, or for example step measurement, but also posture, which has been shown in previous studies. So we tried to investigate whether we can actually use the sensors to get to the well-being or predict the well-being of the person. To investigate this, we had a diary study with about 100 participants who were answered twice a day for 3 weeks. A couple of questions. The one that we were interested in here in the study is the self-reported well-being. And when people answered this question about their subjective well-being, we also got the data on the tilt of the smartphone from the sensor automatically. The tilt of the smartphone means how much the smartphone is tilted in a direction, and this can be inferred from the gyro sensor and then sent with the same answer. In the first study of the paper, we found an association between the smartphone tilt and well-being for the ipsatized data, so within person effect, meaning the more the device was tilted in comparison to the normal position, the lower was the well-being score within each person. So if a person holds the smartphone in normal position and then it's tilted more at a certain point in time, there's also a higher chance of that person having a lower well-being, which was overall a small effect, which is to be expected. We then conducted a second study and tried to replicate this effect. In the second study, however, we only found this effect for Android smartphones, not for iPhones. So there seemed to be a difference of the data or the association for Android and iOS smartphones or smartphone users. And I will give a bit more detail on that now as well. Overall, we found this association between smartphone tilt and well-being, but only for Android systems. And we also identified, which I have no time to go into detail right now, a lot of technical challenges. So it seems that the sensor data is actually not identical between different apps and also not different operating systems, which is why I showed you the results here for Android and iOS. So it seems to make a difference which smartphone you implement and which software you use. And this is actually also now a newer paper which we published, where we investigated different smartphones and showed heterogeneities between different devices and also different implementations of the software. As a conclusion to the entire thesis, the results provide information on the amount of valid data that researchers are able to assess via different response scales and also via different sensors in smartphone-based research. There were advantages of the visual analog scale format with regard to non-response, less dropout. The information assessed via visual analog scale response scales seems to be similar to the one with Likert type scales, although there are some advantages but no disadvantages to implementing it. And objective sensor data can be a viable source of information for social scientists and also practitioners, but you have to address the heterogeneity between devices. Overall, it was shown once again that the methods have a profound impact on the data, the possible analysis, and the conclusions that you draw in your studies, but we also provide some indications of where it is more and where it is less important which method is implemented. Thank you for your attention.